Alright, ladies and germs, we're gonna be going through Metasploitable. And I put all the notes down here to my left, as you can see. And then I am going to practice a lot of the commands here on the bash. So, as you can see here, right? Just by the name of the video, Metasploitable Basics. So if you guys don't know what that is, if you guys don't know what Metasploit is, it's a hacking framework that comes with a bunch of modules, auxiliaries, scanners, etc., etc. It can be used as a hacking framework on its own, right? Again, you can scan for ports, you can scan to see if there's vulnerable services. And if those services are vulnerable, then it comes with those exploits built in that will open up an interpreter shell, and bang, you're in the computer, right? And once you're in the computer, oh Lord Jesus, you don't want that to happen. You're pretty much owned. All your data is owned, all your etc., right? They can even turn on the microphone, the camera on your computer, etc. So that's why you should always be careful on what you click on. That's very important. Alright, so let's continue, guys. So here I start off in chapter 2 because in chapter 1 it's just an explanation of how to install the thing, Metasploit. But if you're using Kali Linux, it's already installed by default. But it's just like installation and just the history of stuff, right, where that came from. You could easily look that up on a Wikipedia page, so you don't really need me. But hold on, guys. I want to make sure that I'm hearable. Hello. Alright, so let's go back over here. So now let's start off with the basic commands, right? So how we run it, we do MSF console, as you can see, right? And that's how we run it in our bash. So now we wait until it starts up, starting with the Metasploit framework console, which in my opinion is one of the most useful of the hacking softwares that you can use. I believe they have paid versions of it too, which I think is just a scanner, and I don't know how much you charge a month, but that would be a cool thing to have. I really do like Rapid7, I believe, who developed this. So yeah, again, I'm a big fan of Metasploit. So let's start off with the basics, right? So we already ran it, right? MSF console. So now we're gonna check out help. So let me just expand this real quick. I'll actually expand it and then I'll minimize it at the same time. Hopefully this remembers it. Let me see that. Let me see so we can read it. Nope. Dang it. Let me see. You know what? Maybe I'll have to make this one a little bit smaller and I'll just scroll it to the right. So when we do need to see what it says, we can see it. So like this, I believe. I think this will do. So let's do this. Let's clear this out and then let's put help. Let's see what kind of information we get, right? So as you can see, these are commands that we could use. So banner is one that's gonna come up soon, which I believe we're gonna use. Where the heck did we use it? I don't see it here. Maybe I forgot to put it, but banner is another cool way of showing you the cool drawing that Metasploit comes with by default. So banner. So you see this here up here. This little drawing here, and then we'll do it again. Banner. This cool one right here. This one. All this right here. Just fancy schmancy talk. Slow coder, circle, and note. Again, we're gonna do banner, another one. Another cool one here. 3com super 2 login. Banner. So here was another one, a shell. I love shells. Obviously referring to the interpreter session, or what we're using now, etc. Right? So let's use help again. Let's go up again. Let's see what's cracking. So change current director, we know that, right? We've used that before. Color, toggle color. Let's see what we get. Nothing. Maybe I gotta put a color at the end. Color red. No, nothing happened. Color. Nah, nothing's happening. So let's keep going up real quick, see what's cracking. Connect, communicate with the host. So I'm assuming this is kind of like a telnet version of something. So let's connect with a computer that has telnet. Let me see. Telnet port. I believe it's 23. It is. So let's do this. Nmap. Oh no, I can't do that. Never mind. Let me see. IF config. Let's use our IP. And again, if you don't know anything about IP addresses, just because I show you my IP doesn't necessarily mean you're gonna know my location, because ISPs, what they do is that they recycle all the same IP addresses, and they all start off with 10s. So it's either 10, 192, or 172. That's why if you do IF config or check out your local IP, it's always going to begin with either 192, 10, or 172. So it's all recycled IP addresses because there's more devices than the IPv4 space is allowed to happen. So as you can see here, right? So I'll copy it, right? So let's just do this. Connect. And then, or let's do this. Let me see. Connect. Let me see if I can connect to my router instead. IPR. This would be the router of my IP address. Connect. 10, 2.35. Again, showing me my private IP address means nothing. Millions of people use their same recycled IP address all the time. It's something you can look up yourself. So you see connected. So yeah, it's kind of like a telnet version of it. So I put a port at the end, right? And the majority of routers all either have the port 80 open or 443. And the reason for this is either because you need to log in via a capture portal, and obviously we've seen that before, or sometimes to adjust the settings of the actual, I don't know why it kicked me out of the whole Metasploit thing, but to actually modify the settings of the router itself. So the port, a router will always have either port 80 open or 443 you can connect to. So that's why I was able to connect and stay connected via the connected command in Metasploit, if that makes sense to you fellers. Connected. Let's see if it works on domains. Google.com, and then we can put 80 port. I believe it's connect, but let's try it. You see, there we go. We connected, but we're not getting anything back. That's what I find interesting. But I guess we connected for some reason. So, oh my god, I did it again. Fuck, man. Let me see. Hopefully on your computer works a little bit better than mine's. So let's just read through these real quick, right? So there's debug for debugging. That's interesting. So we can exit. This one will actually exit just the Metasploit features. Display the list of not yet released features that can be opted into. Get the value of a context specific variable. What is that? I don't see much. Wrap tables, true. Fully interactive shells. Alright, so let's see. So features, gets the value of your context specific variable, get g grep the output of another command, help, history, show command history, load a framework plugin, quit, exit the console, repeat a list of commands, route traffic through a session, save sessions, set G sleep, do nothing for a specified number of seconds, write console output it to a file as well, the screen, threads, view and manipulate background threads, tips, show a list of useful productivity tips, unload a framework plugin. Let me see, unload, unset G, and then module commands, advanced, back, clear on, clear the module stack, favorites, add module to the list of favorites, modules. Then you get to see the actual your favorite modules with your favorites, info, list, load, path, pop, previous, reload all, search, show, handler, jobs, etc., database backend, credentials, list all credentials in the database, developer command, this if you want to do stuff in Ruby, DNS commands, domain name system, manager stuff didn't resolve me, let me see, primary, blah 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 blah. So the help command, it definitely shows you a lot of stuff you could use. But it doesn't show you a lot of other stuff. Like, I don't see anything about scanning networks. It doesn't show you how to do that command, which on my notes we do have. So let's get using my commands. So, okay, help, connect. That's if you're trying to learn how to use help, connect. Let's see if we get more. Okay. Specify to which com to use. Set to use CRLF for IOL sequence. Help, send the contents of a file. Help banner, source. Alright, so and then let's just go down here. Resource scripts, right? So as you can see here, this would be a way to start off a Trojan horse. So if you don't know what a Trojan horse is, it's a program that opens up a shell within the infected computer, and that shell communicates with another computer, and that computer gives it commands. So as you can tell, it's a very dangerous program. So you got to be careful on how you use these, right? Luckily these are for Windows, so Linux by default doesn't run executables. It doesn't run that architecture. So I can double click it and nothing's gonna happen because I'm using a Linux computer. But if somebody sends you this file, or they use it maliciously they'll put it in your computer via malicious USB or something like that, then you're pretty much screwed, right? So as you can see here, right, use exploit multi-handler, right? Set payload Windows interpreter reverse TCP, set else host. So we'll practice that right now, right? So use exploit multi-handler. Hopefully I spelled everything right, which I didn't. Multi-handler, as you can see there. Enter. Using configured payload generic shell reverse TCP, right? So again, this is gonna send a Trojan or a shell program that'll control a computer that double clicks it and runs it, right? So as you can tell, that's no bueno, as they say. That's the lesson you want to happen. You don't want that to happen. No good. That's not good in the hood, as they say. Alright? So, hold on, guys. So that's not good in the neighborhood. So now we're gonna set the type of shell that we're gonna be sending it, right? So we're gonna send one for Windows. So we're gonna set payload, all in capital, and then Windows, which will be our target, Metasploitable. And then reverse TCP. Alright, hopefully we spelled everything right, which kind of looks right to me. As you can, yep, it's right. So now we put the L host listener. So the L host would be the person listening, the attacker, right? What a lot of people do is that they use virtual or private servers for this sort of stuff. They'll use virtual private servers for this sort of stuff with the command and control software. So once somebody clicks out in the wild, their computer will communicate with a private public IP address that's assigned to the specific computer and only the specific computer. And they will be able to pretty much control your computer and everything it does. If they want to do a DDoS attack, they can do that. If they want to check out the contents of your computer, they can also do that. They can do everything, right? So for this example, I'm going to make up an IP address because I don't plan on running this payload. I'm not going to send it to somebody. I'm just telling you what a hacker would do and what they do with this sort of stuff. Remember, I'm showing you the ethical side of hacking and how hackers work and why you should be really careful on what you click and run on your computer. You know what I mean? Don't download anything from shady sites or some dumb made up website you shouldn't be visiting. You'll be like, oh, free money, click here .exe, right? The program, that's what it says. Oh yeah, click, and then you run it, and then your computer's infected, bang, right? And it's communicating with the command and control server somewhere online, right? So I'm showing you how essentially it works. But for this example, because I don't plan on using it, I'm gonna give it a random IP address, or what would be the attacker. Again, I'm gonna use a private one. Private one, 169.69, right? And it will be listening from port. I don't want to make it too suspicious. Normally, you could use port 443. No, excuse me. Hackers normally use port 4444 by default. But a lot of firewalls will pick up on the communication of that. They're like, okay, a lot of the default shells or these Trojans will start communicating via port 4444, but I want to make it look like it's coming from a internet service, so we can do something like this, 443, to hide it, right? And then we exploit. Boom, son. Now what happens is that we wait. Once this person has clicked our executable, it'll show up right here in a list, right? So, because we're running the listener, this is how we actually have our payload right here. As you can see it here, right? But since we're not going to run it, I'm just giving you an example of what the listener side of things looks like. So let's run our payload, which somebody would click. Let me see, interpreter, reverse TCP. Maybe it wasn't put on right. So again, I'm just gonna make one up. 169.69.69. That's gonna be our listening IP address. And then let's do the L port 443. The format type will be executable, and the output will be payload.exe. That will be the name of our Trojan horse. And then, as you can see up there, the listener type, which is this right here, Windows Meterpreter Reverse TCP, Transition Protocol, and then the program that we're going to use to make it, which is MS Venom, right? So let's enter. I wouldn't want to open that. Oh my god, look at that. Save as payload.exe. So now I'm going to press LS. As you can see, this bad boy down here, as soon as someone clicks on it, click, 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 in their Windows computer, thank you. Your computer is my computer now. Alright guys, so at least we're getting an idea, right, of how dangerous Metasploitable could be, and how it could be used in a malicious way, and how hackers actually exploit and try to use this program for the wrong. But in my opinion, these programs are the ones that teach you, as an ethical hacker, what they're doing, and it actually gives you knowledge, you know, because at the end of the day, none of these programs are as powerful if the computer user who they're trying to infect has the knowledge of, hey, I'm not gonna click on random programs, I'm not gonna download random stuff, I'm not gonna click on random links, I'm not, all that, as long as you don't do that stuff, you should be good. And your computer, the chances of it falling victim to a hacker falls down a lot, like very drastically, in fact. So remember that, right? So I'm glad I kind of taught you guys this side of how what do you call it, how hackers use these sort of software to like get into people's computers. And again, it's up to you to avoid falling victim to this stuff, and you don't want to be that dummy, right? So let's continue on. So again, I'm gonna keep payload.exe around just as a little fun example, and I can click it on my Linux computer, but nothing's gonna happen. It's right here, you see it? If I click on it, Windows or EFI program, if I click on it, nothing's gonna happen. I'm running a Linux computer, and if you guys don't know, the CPUs on these different platforms, they take different instruction code to run. Like, you know what I mean? Like, a Windows executable file can't run on a Windows computer, but also a Linux computer you could run on them. I believe it's a virtual. It's called Wine, I believe. Windows, or what's that program called? Hold on. Run Windows applications on Linux. Wine, original accurate. Wine is not an emulator. It is a compatible layer of capable of running Windows applications on several POSIX compliant operating systems such as Linux. Oh wow, Mac OS X, BSD. Instead of simulating internal window logic like a virtual machine or emulator, Wine transfers Windows API calls into POSIX on the fly, eliminating the performance and memory penalties of other methods and allowing to clearly integrate Windows into application. So this is interesting right here. So this is like another thing that, this is another layer of thing that I'm actually might have to go through, but this essentially allows us to run Windows computers, Windows software on a Linux machine. And I find it interesting too, because I guess the way that they programmed this thing was that they run the API calls, which is when you run a program when you run any program, what happens is that it starts asking for stuff on the operating system level to, and you name it, right? It starts asking for all kinds of stuff, whether it's the web camera, just anything that a computer could use to run. Like, what would be a good example of an API? Let me see. Let's see. What is an API in Windows? Yeah, there you go. That's a perfect example. The Windows API, also known as Windows API, is a set of functions and interfaces that allow applications to interact with the Windows operating system. So the operating system is giving everything that you see, like the GUI windows, the colors, the this, that. It's giving all those functions to the application that you're running, right? So the API, this thing right here, I'm assuming it's doing just the Linux version of that, instead of having to be an emulator, where an emulator is just somebody's programming the APIs to simulate those calls, right? So again, guys, this is why computers are a pain in the fucking ass, and they're never easy to fucking learn. So I'm definitely gonna say this for later. That's a cool little thing. So let's go back here. Let's go back to our Windows over here, and we see more executable payloads. As you can see there, list all available encoders. Ooh, so that's another thing, right? That I forgot, that I left out. Encoders. Always make sure you spell everything right as well, because this is a pain in the butt when you get it wrong. So if you guys don't know, encoding is a way of changing the values of characters. So for example, CMD here, right, base 64, this will change the way that code looks. So let me go back over here. God dang it, man. Let's see, encoded code or characters. That would have been the same thing. Actually, I saw a pretty good example over here. Let me see. Was it a video or something? Nah, it's not really explaining anything. That explanation was kind of right. Let me see. I think this would be a good example. Let me find a good one. So here. This would kind of be a good one, actually, but I need to see more of them, right? So let me see if I can do types of encoding. Or maybe this one. So 0, as you see here, right? This can be interpreted with this, which I forgot the name of that sort of encoding name, but it can be interpreted with binary as well, right? So in a programming language, you could, instead of putting like var number equals 0, so you're assigning number to the integer 0, right? But also in the programming language, you can do this as well, right here, 0011000. This could be interpreted as 0 as well, right? So when it comes to encoding payloads, what normally happens is that antivirus programs, they're designed to pick up bad code based off hash signatures. So if somebody were to program a direct just shell code, the antivirus program would be able to pick it up, right? They'd be like, okay, because they're not trying to hide the fact that what you developed was a shell program, which normally what hackers do, well, they'll try to hide it is by encoding the code. So they'll change a lot of the characters and the symbols with this, right? So let's do this. Let me see if maybe I can do this. Base 64 encoded. So maybe we get something like this, right? So yeah, so this would be a good example. As you just saw, right? Base 64. So as you can see here, right? So the numbers are on the left. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yada yada. And then you got the binary versions of it, right? And then you got characters are also represented by binary, right? So as you can see there, so encoding these characters will change it to binary, and the program will run. So it will be interpreted differently, and every program has a hash, a unique hash to it, right? So let's just say you write a program that has, let's just say 60 words, right? And it could be unique, right? To however you write it, it's gonna have a specific hash. So what happens is that an antivirus program is it runs through a database of hashes, and if it sees that the code that you're trying to run, which again is specific to do something, which would be to communicate with the outside source or run a shell, etc., right? So that program will have a specific hash, a specific code, and specifically how it's written. But to try to hide a lot of that, a lot of people will change a lot of the code with binary and other kinds of ways. But let me see if I can find, let me see, different kinds of encoding programming. Could have been a little louder. Come on, am I right? Let me fix the audio that was on the song. Alright, so let's see. I think this would probably be a good example. base 64. Let me see. Oh, Java, one of my favorite programming languages. Java Revisited. Eurobase 64. Let's see if we see some encoded code here. Let me see. Decoder based on 64-bit decoder byte array. The decoder.decode base 64.string string encoding new string byte array. System.out line decoded plus decoded output. So it looks like it's changing the code, the characters. So base 64. What the heck? Alright guys, you know what? I'll continue this video off tomorrow. Just want to do a quick little 30-second video and explain all the little nuances and yada yada that go into the difficulty, honestly, of understanding of how all of this is, like, all a big picture that's just in one frame, right? That it all goes into this one. It's kind of like a car. Like, everything in the car has a function that makes it go, right? Every little piece is important to some degree. Even as something as simple as the disconnected battery post could make the car not work or turn on at all. So it's the same thing with computers and these hacking tools. You have to understand the functionalities behind them and how they work in order for you to understand how they work, right? So alright guys, peace. I'll definitely continue this out tomorrow. Let me see. I was in the encoder part, so I'll definitely start going down these right here. This is a very famous encoder for more use in cases, but this right here, in my opinion, it was good back then, but it's not good now. Just because there's a bunch of antiviruses that already had the hash signature of this. So that's some shell. Inside that's some shell. Armitage. Ooh, I remember Armitage. Cabal Strike. Automation for red teams. Interesting. Metasploit Pro. Remember I was telling you guys that Metasploit Pro probably be worth it. And by pro, I'm saying if you guys can afford it. I don't know how much it costs. I know Nessus, which is the top dog of computer vulnerability scanning, is like $4,000 a month or something like that. It's some ridiculous number. So definitely that.